Hey guys, the chapter is almost over, and I thought it'd be a good idea to look back at the different units that we went over and relearn some of the things that we might have missed. So let's take a closer look at 9.1 first. That might have been a little too close. 9.1 brought us to equivalent fractions. We had 32/48, and we wanted to know what other fractions would be equivalent or equal to that. So we thought about it and we realized we could multiply the numerator and denominator by the same number and get something that would equal the same thing. So we multiplied each by 2 and got 64/96. We also could use division to do this, so we're not working with such big numbers. In this example, I took 32 divided by 4, and then I also divided the denominator by 4 and got an answer of 8/12. So 32/48 is equivalent to 64/96 or 8/12. Now let's take a look over at 9.2. 9.2 took that same principle of finding equivalent fractions, but took it to the next level, or at least the simplest level, and brought it all the way down. So we started with 32/48, and we said, what could we divide into both 32 and 48? And we found 4, and that gave us 8/12. We said, you know what? I think there's another number that we could divide into both. And there was 4. And so we did that, and we got an answer of 2/3. And so 2/3 is an equivalent fraction to 32/48, and it's in simplest form. Moving on to 9.3. 9.3 was a little tricky and a little confusing for some of us, so I really want you to focus on this. All it's asking is about how much of that rectangle is filled up by circles. And just by looking at it, it looks like about half. If you look at the information underneath, that might give you a little better explanation of it. If we're trying to make this pie chart on the side, on the right, that one, and we had the information on the left, this stuff, and we see that Asia had about 48% of the pie chart. We know that 48 is close to 50, and 50 would be half. So when we made the pie chart, we could fill in about half representing Asia. And if you look, that's the black marks. Africa is 22, and we know 25 would be half. So I shaded in about a quarter. 25 would be a quarter. So I shaded in about a quarter of the graph to be green, and then so on with red and blue. Not so hard. Let's move on to 9.4. 9.4 was, again, just rounding. So we had 3/8, and we said that 3/8 is about 1/2. And if you look at the number line, I put in green the ones that we might round to, either 0, 1/2, or 1. When we put a dot at 3/8, look at those 3 blue arrows. The blue arrow going to 1/2 is by far the shortest of the 3 arrows. So that means that 3/8 is closest to 1/2. 9.5 went kind of back to the stuff we learned in 9.1 and 2, where we were taking numbers and trying to find common multiples. Common multiples are a good way to help us find either common denominators or other equivalent fractions. So if we had 4 and 6, all we do is count by those numbers. So for the 6's, we took 6, 12, 18, 24, 30, and 36. For 4, we had 4, 8, 12, 16, 20, 24, 28, 32, and 36. And both of those lines could go on forever. In black, I circled the common multiples, 12, 24, and 36. Common multiples are numbers that we're going to see in both lines, or both sets of numbers. In red, I put a red box on there, and that's going to tell us what the LCM is, or the least common multiple. It's the smallest of all of the common multiples. So in this case, it would be 12. Moving on to 9.6. 9.6 was just taking those common multiples that we found and using them in fractions to find the common denominators. So if you think about it, to find common denominators, you need to use the denominator to find common multiples. So we did that, and when we had 3/4 and 5/8, the denominators are 4 and 8. So we made a list of all the multiples of 4 and all the multiples of 8. And we can see that there's 8, there's 16. If we kept going, we'd find 24 and 32. All of those would be common multiples. I just chose to use 16 as the common denominator. So I renamed that fraction using equivalent fractions as 12/16 and 10/16. That brings us over to 9/7. It does the same thing, but then we're going to go one step further and add them together. For adding fractions, we have 3 easy steps. First, find a common denominator. In the example of 1/3 plus 2/5, I found a common denominator of 15. Then I renamed the equivalent fractions. To do that, I know that I needed to get a denominator of 15, so my denominator was 3. To get to 15, I would have to multiply by 5. So I did that. I multiplied the 3 by 5 and the 1 by 5. You can see it right there and right there. And then I had the 2/5, and I know I had to get that to 15 also. So I multiplied the 5 by 3 and the 2 by 3. Right there and right there. And then I renamed those fractions 5/15 and 6/15. And then for step 3, all you're doing is adding them. So I add the numerators. 5 plus 6 is 11. And I kept the denominator the same. 15, 15, 15. An example of this is if you had 1/4 of a pie and your friend had 1/4 of the pie, together you had half of the pie, or 2/4. You didn't have 2/8, you had 2/4 of the pie. 9/8 is really similar. All you're doing the same stuff, just you're going to subtract instead of add. So we have a common denominator. For 7/10 minus 2/4, I found a common denominator of 20. Then I need to rename the equivalent fractions. To get to 20, I know I'd have to multiply 10 by 2. So I'd also have to do that to the 7. For the 2/4, I know I'd have to multiply the 4 by 5 to get 20. So I also multiplied the 2 by 5. When I rename those fractions, I have 14/20 minus 10/20. In step 3, I subtract the numerators. 14 minus 10 equals 4. And I keep the denominator the same, 20, 20, 20. So that gives me an answer of 4/20. But remember, you always have to simplify your answers. So if I have 4/20, I know I can divide both the 4 and the 20 by 4. So 4 divided by 4 gives me 1. 20 divided by 4 gives me 5. And so in simplest form, 7/10 minus 2/4 equals 1/5. And that's the chapter in only 8 minutes. Good luck on the test, guys. See you tomorrow.